This is Module 4, Lecture Note 7. Today we're going to be talking about how to classify matter. So matter is just anything that has mass and takes up space. So matter is pretty much everything that you can encounter on a daily basis. And there's a way that we're going to talk about in order to classify that matter into different groups. Okay, so let's start by putting matter at the top of our chart because that encompasses everything. And we're going to break it into different categories. So if you can go ahead and fill in the lines of your chart, that would be helpful. Okay, the first type of matter we're going to talk about is something called a pure substance. And if you go back up to the top, I've defined a pure substance for you. It says it's a substance that contains only one element or one compound. Okay, and we know that an element is something on the periodic table like iron or sulfur. It has a chemical symbol. And we talked last week that a compound would be when you combine two or more elements chemically. And see here, salt would be sodium and chlorine combined together. Water is hydrogen and oxygen. Here's the formula for sugar. But what I want you to notice about these pure substances is they have chemical names and formulas. Chemical names and formulas. And the reason for that is pure substances never change. They are the same no matter where you go, whether you're in Indiana or across the world. Salt is always NaCl. An atom of iron is always Fe. A pure substance is pure because it has a defined chemical name and formula. Okay, so on your chart, you are going to fill in that pure substances can either be an element or it could be a compound. And if you want to fill in an example for that, let's see, an element would be something like sulfur, S. A compound could be like magnesium sulfide, one or more elements together. Okay, let me show you a couple examples. Let's say I had regular old water. We talked about that water is a pure substance. It's not mixed with anything. Water is always H2O. It's pure. Same thing for salt. You can see that if I have some salt, each and every granule of that salt looks the same. There's nothing mixed into it. It's all NaCl, sodium chloride. Okay, so if you don't have a pure substance, what you have is something called a mixture. Okay, and I think we're probably familiar with that word. You mix lots of things together, especially when you're cooking or playing outside as a kid. A mixture just combines different compounds and elements mixed together. But the thing to note about mixtures is they can be separated physically. They're not chemically combined together, okay? So you could make a mixture by mixing some Kool-Aid with water, okay? It mixes in. You could make a mixture by adding different kinds of seeds. I have poppy seeds and sesame seeds and pieces of onion in here in my bagel seasoning. That's just a mixture of different seeds. And one thing I like to tell my students is that people make mixtures differently. And that's why they're not pure. Some people mix Kool-Aid and water to be really strong or weak. If I made this mixture of seeds, I could have added more poppy seeds or more sesame seeds. There is no chemical formula or name for these mixtures. Okay, you will not find these on the periodic table. So it's important to know that they can be separated and that also they can differ depending on how you make them. Maybe the person making it makes it differently, or maybe the day you make it, it's different than the day you made it before. Okay, there's not a defined formula for a mixture. There are two different types of mixtures. One is called a heterogeneous mixture. And hetero means different. Okay, and so in a heterogeneous mixture, you're going to see a different composition throughout, or you're going to see chunks. You're going to be able to see pieces of something generally in a heterogeneous mixture. I gave you some examples. Sand mixed with water. You can see that the sand and water are different from one another. Orange juice with pulp. The pulp is different from the juice. It's mixed together, but there's different components to that mixture that can usually easily be separated out. Okay, a homogeneous mixture. The word homo means same. So when you look at a homogeneous mixture, it's going to look all mixed in. It's going to look the same throughout. And that's often called a solution. Okay, so some examples would be salt water. If I have my water and my salt and I dump a little bit of salt in there, once it's all mixed together, it's all going to look the same throughout. Gatorade, you can't see any pieces in there. It's a solution. Milk, air is even a solution, or a homogeneous mixture of different gases. Okay, so that's important to know that it's going to look the same throughout. So that is homogeneous. Okay, I'm going to give you a couple examples, and I would like you to pause the video and take a few minutes to tell me whether you think it's an element, a compound, a heterogeneous mixture, excuse me, or a homogeneous mixture. Okay, why don't you do T? We'll do helium. Let's do baking soda, which is sodium bicarbonate. And let's do dirt water. Okay, my kids mixed some dirt water when they were working outside yesterday. So why don't you take a second to do those three. Tell me if you think they're element, compound, heterogeneous, or homogeneous. Okay, so I'm going to work through these examples with you so that you can see how we will think through classifying all types of matter. Okay, so you're always going to start at the top of your chart because everything falls into the category of matter. Then you must decide, is it pure or is it a mixture? So let's look at tea, like tea that you would make with a tea bag and water. Is it pure or is it a mixture? It is a mixture because it can vary in the way that it's made. You could add 2 tea bags, you could leave it in there for a long time and make strong tea or weak tea. You get the idea. It can differ. So it's a mixture of tea and water. Now you must decide, is it heterogeneous meaning does it have large chunks or pieces, or does it look the same throughout? And T, when you look at it, it's a solution. It looks the same. So we're going to call this a homogeneous mixture. Okay, so you start at the top of your chart, very general, and you work down to the most specific that you can classify this. Helium. What do you think? It's a pure substance, and it is found on the periodic table. It's an element. So that means helium will be the same no matter where you go. It has a specific chemical formula. It's an element. What about baking soda? You will often see on your homework that some things do have chemical formulas next to them. And that should be a dead giveaway that it's a pure substance. Baking soda is a compound. Sodium, hydrogen, carbon, and oxygen are chemically combined into a specific formula for baking soda. There's nothing mixed in. It is pure baking soda, sodium bicarbonate. It's a compound. And then I'm sure you can guess dirt water. Okay, let's say my kids gave me some water, they dumped some stuff in, we stirred it up, and we have dirt water. Okay, it is definitely a mixture. We could have added more dirt, less dirt. It's a mixture with lots of chunks in it. We're going to call this a heterogeneous. Heterogeneous mixture. The thing you should also note about heterogeneous mixtures is that they're really easy to separate. I could just pour this through a filter and I would have my dirt and my water separate again. Okay, so that should help you with those. One example that often trips students up is air. So let's talk about it. How would we classify air? Is it pure or is it a mixture? And I think if you're not sure between those two, you want to ask yourself the question, is air the same no matter where I go on this earth? Is air in Indiana the same as it is in Los Angeles? Air has lots of different gases in it. Hydrogen, nitrogen, lots of oxygen. But those can be in different proportions depending on where you are. There could be pollution in the air. Air is a mixture. It is not a pure substance. Okay? It's a mixture of different gases and it looks the same throughout. You cannot generally see anything in the air. So we're going to call air a homogeneous mixture. Okay, so hopefully that helps you think through that example. Let's go ahead and flip over to the back of your page. And we're going to go through physical and chemical changes. A physical change means that you are just changing the physical nature of a substance, but you are not creating anything new. It says a change in which the atoms or molecules in a substance stay the same. I'm going to write nothing new is formed. So let me give you an example. I have this piece of paper, okay, and I rip it in half. I had paper before and I have paper after. It might look different, but it's still paper. Nothing new was formed. That is a physical change. A chemical change, on the other hand, is a change in which the molecules or the atoms actually form a new substance. And I'm going to write a reaction occurs. A new substance is made. So if I took that same piece of paper and I lit it on fire, we all know it would burn It would turn black, it would smoke, and I would be left with ash, which is a new substance that I did not have before. So that would be a chemical change. There are 4 indicators that you can watch for that will help you know a chemical change is happening. And the first one is a color change. If your substances change color as a result of a reaction, that is telling you that this is a chemical change. A temperature change. If you mix 2 things together and they get hot or cold as a result of the reaction, a chemical change is happening. We're going to say a gas is formed. The way that you would know a gas is formed is you would often smell it, or you would see bubbles forming in your solution. So a color change, a temperature change, a gas forming, and the last one is probably a new word you haven't heard before. A precipitate forms. Precipitate. Okay, if you mix 2 things together, like 2 liquids, and a solid forms, that's called a precipitate. And that often happens in a chemical change. Color, temperature, gas, precipitate. Those 4 things, those 4 indicators, you do need to know. Okay, the last tip I'm going to give you before we practice some of these is in many of these examples, someone will be cooking something. Cooking, chemical. Cooking is always a chemical change. A new substance is created as a result of a chemical reaction. Okay, so we're going to try a few of these. I would like you to either put a P for physical or a C for chemical. Go through these and ask yourself, did I create a new substance or did I just change the physical appearance? Okay, and then come back and we'll go through these together. All right, I made some ice cubes. Physical. I had water that was liquid and I froze it and it's solid. It looks different, it changed phase, but it's nothing new. It's a physical change. The ring tarnished. Tarnished is like when a metal turns a different color. That is a chemical change because a reaction is happening between usually your skin and the metal. And the way that you know is you see the color, and that's telling you that it's a chemical change happening. My ice cream cone melted. Oh no. I had ice cream before, I have ice cream after. It's a physical change. After a summer of fun, my arms and legs were tanned. A reaction is happening in your skin cells. They are changing color. Chemical change, turning tan. All right, I mixed salt and water. What do you think? Physical or chemical? This is a physical change. I had salt and water separate. I had salt and water together, but a new substance was not formed. I still have salt and water, and they could be separated back out again. This is a physical change, and you do not see any of these indicators happening. And then lastly, we grilled cheeseburgers. Cooking is always chemical. You smell the cheeseburgers cooking. The color of the meat changes from pink to brown. Cooking is chemical. Okay, so hopefully that helps you with a few examples. These just take practice to get the hang of, but if you really remember these 4 indicators, that will help you think about physical or chemical. right, the last thing we're going to talk about today are phase changes, because physical changes are often phase changes. Phase changes are physical. Okay, they are changes in the state of matter due to adding or taking away energy. Okay, so let's talk about going from solid to liquid. Okay, I add some energy, the molecules start to speed up and they move faster. What is this called when I go from solid to liquid? Maybe think about it in terms of water. Solid water becomes liquid water. This phase change is called melting. What about the opposite? What if I have liquid water and I take away energy and it becomes a solid? That is called freezing. All right, let's go over here to our liquid phase. Let's add some energy. The molecules start moving really, really fast. What is it called when I go from liquid water to a gas, water vapor? That's when your liquid starts boiling, or evaporation. And then we can go the opposite way. I have water in the gas form, or any substance in the gas form, and I take away some energy. The molecules slow down to be a liquid. This is called condensation. You often see that in the morning on the grass. Water vapor's in the air. Overnight it cools down and you end up with condensation, or dew on the grass in the morning. All right, I'll give you one more for those of you that like kind of nerdy science stuff. You can actually go straight from solid to a gas and skip over the liquid phase. This is called sublimation. Okay, I love giving you guys real world examples of where you find these science things in your everyday life. So sublimation, where do we see it? How do we see solid going to the gas phase? Well, one place is usually in your freezer, in your ice box. Okay, so you have solid ice. Have you ever noticed that some of the ice cubes, usually the ones way down in the bottom, are kind of small? Where did that solid ice go? There's no liquid water in here. This ice sublimed. It went straight from the solid phase to the gas phase. And that happens each and every time you open your freezer to get some ice. Sublimation happens, and that solid ice actually goes straight up into the room as water vapor. And that's why sometimes you have little tiny ice cubes hiding in the bottom of your ice box. Kind of cool, kind of nerdy. All right, thanks for listening, guys.